In this video, I'm going to go through the 6-1E lesson, simplifying square roots. First off, we're going to look at some of the properties of square roots. First of all, with a square root, this symbol is called the radical, and the number inside is called the radicand. Our first property is going to state that if we have the square root of a times b, or ab without the times dot would be the same, that we can square root each one individually, um, and these will be equal, or vice versa. If for some reason they are separated, we could multiply the radicands together if that suits whatever the problem needs. If this works for multiplication, the same can be said for division, that the square root of a over b is the same as the square root of a over the square root of b. So we can apply the square root to each part, the numerator denominator. And the third thing is that the square root of a squared plus b squared, so the square root of the quantity a squared plus b squared, is not equal to the square root of a squared plus the square root of b squared. This actually came up in Module 5 with exponent properties, that we could not apply an exponent over addition and subtraction. In the same manner, we cannot apply a square root over addition or subtraction, that this is in understood parentheses. And we're going to look at our first example, and there's kind of two strategies, as well as you can mix these strategies. We're going to start to simplify non-perfect squares. So the first strategy is that you're looking for perfect squares. And so we might say that this is equal to a perfect square that goes into this is 4. And then we can square root using the property above each part. And the square root of 4 is 2. And the square root of 10 does not have any perfect squares in it other than 1. And so that is our simplified answer. That's what we're looking for. And just like simplifying fractions, there are different ways to get to this, but there's only one answer that's considered completely simplified. So when you're checking with a key, if your answer is not equal to the answer on the key, the first thing I would look for is maybe your radicand is not fully simplified. Maybe there's another perfect square in there that you have to extract. And then option 2, which will obviously give us the same answer, would be that we would look at the square root of 40 and we would do some sort of factor tree. I'm going to prime factor this, which is sort of overkill in that I don't want to actually prime factor with some of the problems today because it will just take an immense amount of time. But this is the prime factorization. And then I'm going to look for pairs of numbers. And when I have a pair, I like to circle them. And that means that I'm going to pull out what I like to call one representative. And because 2 times 2 is 4. So essentially we're saying the square root of 4 is 2, because a 4 is 2 2's. I like to underline the stuff that does not have pairs, and that goes back in as my radicand. And so my answer would be 2 root 10, which is what I had above. And I can probably skip this middle step after I've done this a couple of times. But I just want to make sure that I don't leave something dangling in my factor tree and not somehow incorporate it into my final answer. And so this is read as 2 times the square root of 10, or 2 root 10, with a times dot there that we don't normally write.